On this occasion, what they ask us is that we calculate all the rectangles that have a certain area, whatever it may be, which one has the minimum perimeter, that is, that we determine those measurements so that having the same area it has the smallest possible perimeter. As always, we are going to call the base x and the height we are going to call it y.
The area of this figure is x times y. And although it may seem strange, this is the relationship that links the two variables, because this a is a number, it is a constant. If we had been told of all the rectangles whose area is 5, this would be x times y equal to 5. In this problem, what we are going to do is work with a letter, with a constant, whatever it may be. The function they tell us we have to optimize is the perimeter function. The perimeter of the rectangle is a function that depends on the sides and is the sum of its 4 sides. Therefore, 2x plus 2y, we have already seen it on occasion, x plus x, 2x, and plus y, 2y. Since we already have the relationship that linked both variables, from here we can solve for y and we will have that I is equal to divided by x. And this is the relationship that I am going to substitute in the formula. So instead of having a function that depends on 2 variables, I'm going to have just one function that depends on x. 2x remains the same plus 2 times y, which is equal to x, that is, 2 times equal to x. If we want, 2x plus second matched by x. This is going to be the function that I have to optimize. So we differentiate and f of x would be equal to the derivative of 2x, which is 2 plus the derivative of a quotient. It is a particular quotient because the numerator is a constant. In any case, we are going to derive it as the derivative of a quotient to review these types of formulas. The derivative of the numerator, which is 0 times the undifferentiated denominator, 0 times x, 0, minus the numerator 2a times the derivative of the denominator, which is 1, therefore 2a times 1 2a divided by the denominator squared x squared squared. X squared. This is equal to 2x squared minus 2a over x squared. This is the first derivative that, as we know, to calculate the extremes, it must be equal to 0 for a quotient to be 0. It is evident that its numerator must be 0. Therefore, I will have 2x squared minus 2a equal to 0. We simplify the 2's and I would only have x squared minus a equals 0, or what is the same, x equals plus or minus the root of a. It is clear that of the two values, since they are measurements, distances, lengths, the negative value is not going to work for us. We only take the positive value of this network. For that, as always, we calculate the second derivative. Much easier to differentiate here than to differentiate here. But hey, it would be the same if we differentiated here. We would have the derivative of 2, which is worth 0, and now the derivative of the quotient, which would be the derivative of the numerator 0 times the denominator without differentiating, therefore 0 minus the numerator, which already has a minus sign, becomes a plus sign due to the derivative of the denominator, which is 2x divided by the denominator squared x squared squared x to the 4th power. We simplify the x's and here we would have an x cubed and I would have here 2a times 2, 4a divided by x cubed. We evaluate the second derivative at the root point of it and I will have 4a divided by x, which is the root of a cubed. Whatever this is worth, in any case this would be 4a over square root b cubed would be a times the root of a. We simplify the a's and we would have 4 roots of a divided by a, which is a positive quantity. Therefore, since this is positive, it is clear that it presents a minimum for our function. They ask us for the measurements of the field. Let us remember that they do not ask us for anything else, but the measurements of the field. Therefore I have to give the answer that the field, or the enclosure, or the rectangle is a square with the root side of a. Because if x is the root of a, the I would be equal to the root of a, which simplifies the omega the root of a. And up to this point we would have the problem solved. The problem is solved.